Now let us define what interval notations are. Interval notations are often being encountered when it comes to finding the solution set of a certain equation. Now interval notations are intervals basically, and they contain these values or this range of values wherein these values are true for a given equation. So let us define some of the notations which are to be used in the trigonometric, the arccosine, the arcsine, and the arctangent. So if our equation or if our notation is written as x is an element of 0 and 4 pi, that means that x is equal to, this is the first one should be element, okay? Some are not clear. So this means it's an element. It's like E. It's like epsilon, okay? This is a Greek letter meaning epsilon, and this is used to indicate that x is an element or it's a member of the given notation. So if it's written as this one, this is a bracket, or is it a brace? It's a brace. I'm sorry, it's a brace. Okay, so it's a brace from 0, 4 pi. That means that your x is from 0. Take note of the word from. So 0 is still included, up to 4 pi. So 4 pi is also included, meaning it's a closed interval. Okay, meaning that all the boundaries, the left boundary and the right boundary are included in the solution set. So this is a closed interval, meaning that if we are to graph it in a number line, then we could see closed points there. Okay, if it's written, if the notation is written as x element of parenthesis 0, 4 pi, that means that x is in between. It's in between 0 and 4 pi, meaning 0 and 4 pi being the left and the right boundaries are not included. And so this is called as an open interval. And if you graph the notation and the number line, the graph must have open circles at both boundaries 0 and 4 pi. So if this is half open interval, the notation will be written as here. We have closed on, we are closed on 0, meaning that 0 is included, but we cannot take 4 pi because it's not 4 pi is not included in the solution set. So this is also called a half open interval, where we have a closed point at 0 and an open circle at 4 pi. For x element of 0, parenthesis 0, and 4 pi, we have a brace at 4 pi. That means that x is not included, but 4 pi is included. And it's also a half open interval with an open circle at 0 and a closed circle at 4 pi. So this is how these notations are interpreted with respect to the finding of the solution set of a particular equation. So let's go to example number 2. Solve the equation for tangent 2 theta is equal to -5 algebraically for the first 3 positive values of theta. Verify the solutions graphically. Okay. So in this case, now let me go back to the to the previous video, and as you can see, this is the content of the previous video, and it says that we have to verify the solutions graphically, meaning that we have to graph them into a graphical interpretation, and we will get actually these values. The first value is 3.6462. Okay, that's when we get pi minus sine -1 of -0.3. 3. Okay, and that means that it's within 0 up to, okay, within 0 to 4 pi. So why did we cross this out? If we are going to graph this, the location of this sine -1, -0.3 would be x is -0.1046, and -0.3 is actually here. Okay, this is where sine -0.3 is. This is the hypotenuse 1. Okay, and this is the opposite, which is 0.3. In this case, this is negative. So this is our x. Okay. What's happening here again? So this is the arcsine of -0.3. And if we add 0.2 here, it still lies below the, what do you call this? Below 0. Okay, it's still negative. And then we will find the next arcsine by adding or by subtracting it from pi, so it would be on the third quadrant. Okay, but remember the rule that to find the pair, we have to reflect it against the vertical axis. That's why we will have this angle, and this angle actually is also -0.3, right? Because that's negative sine, okay, where sine is negative. So this is where it's greater than 0. So, and this value appears to be x is equal to 3.4 or 6462, which is the second angle in the series of the angles limited in the domain 0 to 4 pi. And after that, we again reflect it. So we will just add 2 pi to it. That means it's one circle. Add to it another circle. So that would be, the location is for the first, after the first circle, we have this one for the 2 pi, and for the 4 pi, it would be here, but that wouldn't be included anymore because it's more than 4 pi already. So we have to take that out. Okay? But we could also take the solution obtaining this, okay, and the other one, it looks a bit complicated, and so this is the last solution. Okay, now let's do it on this example. So solve the equation for tangent 2 theta is equal to -5. So to start with, okay, but remember, we have to remember the general formula for tangent. We have instead of 2 pi, which is exclusive for sine and cosine, we have x is equal to tangent -1 of a certain constant plus pi n, or that's also in degrees, it's 180 n. Okay, So let's solve this problem. We have 4 tangent theta, or 4 tangent 2 theta is equal to -5. So tangent 2 theta is equal to -5 over 4, and so 2 theta is equal to the arctan of -5 over 4. Okay, and theta, well, following the general formula, we have to add 180 degrees there. And so our theta would be equal to, now it's a general consensus that when you have theta, the answer should be in degrees, okay? But when you have something like x, then the answer should be in radian. Okay, so theta here would then be tangent or arctangent of -5 over 4 plus 90 degrees n. So the arctan of -5 over 4 over 2, and that would be arctan -1 of -5 over 4 plus 90 degrees n. Okay, so what are the solutions here? Let's solve. So this is in degrees, so we have to put degrees here. Okay? Okay, the first solution should be, let's do this as when n is 0, let's say. Okay? When n is 0, we have 5 negative divided by 4 is equal to -1.25 inverse the tangent. Do we have tangent here? Here. Okay. Plus 0 divided by 2. So that would be still negative. So n is equal to 0. Then we will have tangent or arctangent -5 over 4 plus 0 all over 2. So the answer here is -25.67. So theta So where are we when we are when we have n is equal to 0? So that means that theta is equal to the arctangent of -5 over 4 over 2, and we have solved that, and theta is equal to -25.67 degrees. Okay, this is the first find. So let us box it. This is the first find. It's -25.670. Okay, now we go to when n is equal to 1. And that means that we will have 90 degrees times n. So meaning that for here, okay, so let's do that here. That would be, we'll start from the beginning again. So that would be 5 negative divided by 4 is equal to inverse of tangent, and add 90 times 1, okay, when n is equal to 1. that's equal to 38.6598 divided by 2. That will give us 19.32. Okay, or I think I made some clarifications here. This would be 90 and it's not. Oh yes, what happened here? Okay, so this should be divided by. Okay, sometimes it's confusing. Okay, so this one will be here. Okay, so this is our final answer, right? And this is the final general solution, and then we have negative 25.6700 for n is equal to 0. Now when n is equal to 1, when n is equal to 1, then our theta is the same. That's just negative 25.6700 degrees plus 90 degrees times 1. So that would give us, that would be 90 minus 25.67. That would be 64.33. But having the original, so this would be theta is equal to 64.3300 degrees. Okay, this is the second fine. Okay. Now, what is our third fine when n is equal to 2? So, when n is equal to 2, that means that we will multiply this by 2, 90 degrees times 2, that's 180. So, our theta then would be equal to negative 25.6700 plus 90 degrees times 2. And that would give us a value which is 180 minus 25.67. That would be 154.33 degrees. Okay, this is the third fine. Okay, so what else? Well, we have to take another one because we are short of the positive. Now, as you can see, all we need to get here are the first three positive values, meaning that this can't be accepted. Okay? Now we have boxed it just to uh, show you that this is one of the solutions found by getting the general formula for the arctangent of the given value, the given ratio. So we are not finished with that one because we still have to get the last positive value, which is when n is equal to 3. Okay, that means that our theta will be equal to negative 25.6700 degrees plus 90 degrees times 3. And our theta here will be equal to 270 minus 25.67, and that's equal to 244.3. Okay, so these are the first positive values, or first three positive values for example number 2, and they are separated by 2 theta. Okay, so let's move on to the next example.